Okay, so on Tuesday, we started looking at functions. And just a quick review of what functions are is a function is a correspondence. And it's correspondence between two things. We'll call them variables, since we're in algebra, and when we don't know what things are, we use variables to represent those. Now, it's a special type of correspondence. So where the first value can only correspond to one second value. And the set of the first values, which we call components, we call that the domain. And the set of all the second values components, we call that the range. And since we are creating a correspondence between two variables, we've already done this. And we did this back in chapter 1 when Rene Descartes created the coordinate plane. That's exactly what he did. He created a correspondence between two variables, one of which we called X and the other we called Y. So this has already been done. And since when we describe a point on the coordinate plane as an ordered pair, if you got some point out on the coordinate plane, you call it X and Y. X and Y represents the two components in this thing called a function. So the set of first values, the thing we call the domain, this is our input. So back in chapter 1, when we were gosh, you're going to do this on the test if you haven't already taken the test. You're going to do this. You're going to be given an equation, and they're going to tell you, here are a set of inputs. They're going to tell you what x's to put in. So you're going to take that set of x's and you're going to input it into the equation. And what you get when you input the x's, you get a y. You output a y. So the range we call the output. And typically, although there's nothing sacred about this, the set of inputs, the set of the first values, we use X to represent those. And we use Y to represent the set of outputs. Like I said, there's nothing sacred about those two variables. Why they started using X and Y and not A and B, or I don't know, but that's what they started to use. Thank you for putting in your attendance. And when it was just Alexandria and I wasn't worried about it, but now that other people are showing up, if you go ahead and type your name into attendance, I'd appreciate that. So that's what a function is. A function is just a way of defining a correspondence between two variables. That's all it is. And with that one caveat is that you can't have one input going to two different outputs. One input has to go to exactly one output. Can't go to more than one. So that's what a function is. Now, typically, we describe functions using equations. And that is an equation that describes a function because, again, what does a function do? A function takes some input, you plug it in for your variable, whatever that input is, and then you get an output. So for this function, if we input 1, we output, is that 6? And this input-output pair represents an ordered pair that's on the graph of whatever this thing is. So if you were to graph this, the 0.16 would be on the graph of this function. Now, since we're talking about functions, and that's all we're going to talk about for the rest of the chapter 2 and chapter 3 and chapter 4, we create a special notation for this function. And you can use any letters that you want, any variables you want to represent it as a function. But as soon as you have a variable in parentheses and another variable, that typically designates that that equation is a function. So instead of using y, we use f of x. Now, as soon as we write it like that, number one, you know it's a function, and you know what the input is. The input's x. And you know what the output is. The output's f of x. So now you can evaluate that for any input that you have, and then you can find the output. So whatever input you want to put in there, you can get the output. So here's an example of a function. F of x equals x squared plus 6x plus 4. And I know it's a function because of the f of x notation, but I also know it's a function because of the nature of the equation. So if I input an x, like -2, what do I output? I output one number. I don't output 2, I don't output 3, I only output 1. In just a second, we're going to graph this on our calculators. So you can see that the graph is the graph of a function. That's all your calculator will graph. It won't graph anything but functions. That's all it graphs. So if you can put it in your calculator, then it's a function. Okay, but let's talk about the domain of this thing. And I'm not going to talk about the range because it's a little early in our discussion of functions for us to figure out what the range of this thing is, because it has a unique range. If we look at the domain of this thing, what's the domain? Well, can you think of any real number you can't plug in for x? Can you plug in a fraction? Can you plug in a square root? Can you plug in pi? What can't you plug in? So is there a number you can't square it? Is there a number that you can't multiply it by 6? Is there a number that you can't square it, add 6 times it, and add 4 to it? So you can put any real number you want to into this function. You can input anything. You can input anything. So the domain is the set of all real numbers. That's not true for every function, but for this particular function, you can input anything you want to. So the way we write that's from -infinity to +infinity. So can I evaluate this function at -2? Sure, why not? So how do I do that? To evaluate a function at a particular input, I replace the variable that represents my input, x, with that number. And you notice I'm doing it with parentheses around it because it's negative, and it's just so much. I'm going to put you on mute for just a second. Now I'm off mute. I saw that was a Redlands number and I thought it was urgent, so I thought I better hang it, better answer it. Anyway, where were we? So domain. So again, how do I evaluate this at -2? Well, we replace the x with -2 and then carry out the arithmetic. So we have -2 squared plus 6 times -2 plus 4. Okay, so -2 squared, when I square -2, I get +4. And then I have 6 times -2, that's going to give me a minus. Let's make that a minus. 12 plus 4. So that's going to be what? -8 plus 4 or -4. So if I input -2 into this function, I output -4. So -2, -4 is a point on the graph of this function. We have an input-output pair. When I input -2, I output -4. Okay? So what can I evaluate this function at? I can evaluate this function at anything, at absolutely anything, as long as it's in the domain. And the domain is not restricted at all. The domain can be absolutely anything. So I could, for example, evaluate this at A. If A represents a real number, I can do that. So how would I do that? Well, I just replace the x with an a. So I can evaluate this function at absolutely any input as long as this input is a real number. Okay? So that leads us, let's continue. Let's evaluate it at -1 then. Can I evaluate it at -1? Sure, why not? Because -1 is in the domain. It's a real number, so I can evaluate it at -1. So I replace the x with a -1, and you notice that I'm doing it with a parenthesis around it to make sure I don't make a sign error. Okay, so now square -1 minus 6 plus 4, we get -1. So evaluate it anything you want. As long as it's in the domain of the function, you can do any kind of evaluation you want. Okay, how about f of 0? Where there's an x, we're going to put a 0. So again, the 0.04 would be on the graph of the same. So let's talk about this a minute. When x is 0, if we draw the coordinate plane, x is 0 on the y-axis. So when you evaluate a function at 0, you're finding the y-intercept because sorry, my internet connection was telling me it was unstable. So if we evaluate a function at x equals 0, we're finding where this function crosses the y-axis, where there's a point with the x-coordinate of 0, and an x-coordinate of 0 is on the y-axis. So this is the y-intercept, 0, 4. So this thing, whatever it looks like, crosses the y-axis at 4. Okay, so before we move on, let's take out our calculators and let's graph this thing. Because when you got a $120 paperweight, you might as well use it. So let's graph it. And I'm going to show you that your graph, you can actually evaluate your function for particular real numbers. Your calculator can do that for you. Okay, so I'm going to share my calculator. And we were doing statistics earlier, so let me get out of there. Okay, so now I have my calculator open. And I'm going to go to my y equals, and that's where I graph functions using my calculator. So that y equals, that is where I input my function. And I think I have something in there, so I'm going to just clear it out. So I'm going to hit clear. Okay, and now I'm going to type in that function, which we had x squared plus 6x plus 4. Okay, so to type that into my calculator, I first must find my variable x. And my variable x is this button right to the right of the alpha key. So you have that green button on your calculator. I don't know what it is on the TI-84. Get my calculator out. What color it is. It's green. So it's the green button. So just to the right of the green button is your X button. So I'm going to click that. And now I'm going to square it. So you have over here on the left, right in the middle, your x squared button. So if I click that, that's going to raise whatever that is to the second power. Then I had plus 6x, so plus 6x plus 4, plus 4. Okay, so now I have my function inputted into my calculator. So I have it in there. So now I want to graph this. So across the top, right below your screen, you have a series of buttons. The y equals, which is what we're using here to input your function. Then right next to that, we have a window. And this helps us adjust the window of our coordinate plane. So you can adjust it to whatever minimum x, whatever maximum x, what minimum y, maximum y you want to adjust it to. So that's how you adjust the coordinate plane's window, what's displayed. Now the next button over is the zoom. And this is typically where I start when I'm graphing. Because if I go to my window, just FYI, if I go to my window right now, the window's adjusted to the problem I did previous. So the window adjustment's all out of whack. So I'm going to go to the zoom. And you have a bunch of standard zooms. Box, it makes it box. Zoom, you can zoom in, you can zoom out. You can do a decimal zoom and a square zoom. And the standard zoom is usually where I start. That's number 6, Z standard. Because if you do a standard zoom, that sets your window in the x direction from -10 to +10. So x, the minimum x is -10, the maximum x is 10. And it sets the scale to 1. And it sets the minimum y and the maximum y the same, -10 to +10. So it sets the standard window from -10 to +10. And that's usually where I start when I'm graphing. So I'm going to do number 6. And then you can see the graph of this thing. And it is a function, which I knew. If I can type it into y equals on my calculator, it's a function. It passes the vertical line test, so it is a function. And I can look at some things at this. First of all, it doesn't look like it has nice, pretty x-intercepts. It looks like its x-intercepts are maybe irrational. I mean, it looks like it crosses somewhere close to -3 and -1, but not exactly. And I could figure out what the x-intercepts are. We could talk about that later. But I did show you that when I evaluate this function at 0, I got 4. So I do see that the y-intercept is at 4. Okay, now I can calculate all that stuff I just did. I can let my calculator do that for me. So if I want to evaluate this function at -2, which is the first thing I did, I can calculate that. So at the top here, above these buttons, you have 5 blue things, text things. You have stat plot. We're not going to worry about that. You have table set, which we probably won't do. You have format, which we're not going to do. But we have calculate and we have table. And those two we're going to be interested in. So the first thing I'm going to do is look at my calculate menu. So I'm going to do, to get to the blue, I need to click the blue key. So the second key over here on the right gives me all the stuff in blue, all over the face of this calculator. If it's in blue, I get to it from the second button. So I'm going to go second, calculate. And number 1 is value. And what this calculates is the y value for a given x. That's what it does. And if I click enter, you see down at the bottom of my window, it says x equals. And it's waiting for you to tell it what you want to evaluate y for. So it's waiting for you to tell it what x you're going to evaluate this function at. So I'm going to evaluate it at -2. So I'm going to go down and use my negative button, -2, and then hit enter. And I believe that's what we found, isn't it? That when x is -2, y is -4. Well, that's nice. So your calculator will evaluate a function at a particular real number. It will do that. So we evaluated it at -1. So let's do that again. So second, calculate, value, -1. And we got -1, right? Well, that's correct. So if I evaluate this function at x equals -1, I get y is -1. So the point -1, as you can see the cursor blinking, is a point on the graph of this thing. Okay, and then we evaluated it at 0. So second, calculate, value, 0, enter. And sure enough, and by the way, it does tell me what function it's evaluating up here at the top. At x equals 0, y is 4. Now you could also look at the table, and the table will list ordered pairs on the graph of this thing. So you can see when x is 0, y is 4. When x is 1, y is 11. If you arrow up, you can see when x is -7, y is 11. When x is -6, y is 4. What did we evaluate? At -4? No, -2. When x is -2, y is -4. When x is -1, y is -1. When x is 0, y is 4. So what this table gives you is the set of ordered pairs that are points on the graph of this function. Now, it's not every ordered pair. There are an infinite number of ordered pairs on the graph of this thing. But it gives you the integer ordered pairs. So it gives you the integer values for x and the y value for that integer. So it's pretty handy little thing to have. Now, what it doesn't do is evaluate your function at something that's not a real number. And that you're going to have to do by hand. Pretty spiffy little tool you got here. I'm going to go back and share my iPad again. Okay. Same function. Again, what can we evaluate this function at? We can evaluate this function at any value that's in its domain. And then we already established that the domain of this function is the set of all real numbers. So there is nothing I can't plug in for x. So can I plug in -x? Sure. Why not? So what I do is wherever there's an x, I put in a -x. Why not? Why can't I do that? So f of -x is -x squared plus 6 times -x plus 4. So wherever there was an x in my function, I replaced it with a -x. And what do I get? Well, if I square a negative, that makes it positive. So f of -x is x squared minus 6x plus 4. So we get something different than what we started with when we replaced x with -x. Now, what's the second one mean? We have negative outside of the f of x. Well, what this means is to take this function and put a negative in front of it. That's what that means. So it's take the function and put a negative in front of it. So to do that, I need to put that function inside parentheses. If I'm going to change its sign, which is what that negative tells me to do, that negative in front of that function symbol says to change the sign of the function. So we take everything that's in the function and we change its sign. So we distribute the negative across. And we can do that, do whatever, pretty much whatever we want, as long as it's in the domain and as long as we're just changing the sign of the function, we can do that. Okay, well, what about this? Okay, so now what are you evaluating the function at? You're evaluating the function at an algebraic expression. Can you do that? Sure. If this algebraic expression represents a real number, I can plug it in for x. Anything I want to, I can plug in for x. So what do? Well, wherever there's an x, I replace it with an x plus h. Wherever there's an x, I replace it with x plus h. So what do I get? Now, you think that's not rocket science there, that you can replace the x with the x plus h. What does the x plus h represent? Well, it represents a teeny bit more than x. So for x were 2, a teeny more than 2 would be x plus h. Just a little bit more than x is what that represents. So how do I do that? Well, I have algebra to do that. I can square this binomial. To square a binomial, what do? I take the first term and I square it, x squared. Then I take the two terms, I multiply them together, x times h, and then I take that and I multiply it by 2. Then I take the second term and I square it. So I've squared that binomial. Then I can remove the parentheses by distributing the 6 across. You've just done calculus. I'm not kidding you. You just did calculus. Now there's a little bit more to this problem to get it purely calculus. And we'll do that in the 1230 class period. But this is the fundamental way that we find the derivative in calculus. And again, being that you're in college algebra, there's an assumption on my part, whether that's true or not, that you're STEM students and you're going to move on. It is my sincere hope that you move on in mathematics and that you continue your studies, because it's where the money is, folks. In math and engineering is where the money is. So my sincere hope is that you do move on in mathematics, that you don't find this to be your terminating class, that you move on. And to be able to do that, you need to be able to take calculus. You need to be able to do this. And we'll expound on this in the 1230 class period. And that's all I wanted to show you today for review. Are there any questions? No? Well, I'm going to let you go a little early if there aren't any questions, and we'll see you back here at 12:30. Okay? All right, we'll see you back at 12:30.